Hello, good morning. I think we can start now, no? And I'm also recording this session. Okay, so before I proceed with the new lesson today, so ko lang ipakita muna yung ano, no? I've mentioned na from the previous lesson, um, ito munang ano, no? Let's start here. So one thing I didn't parang highlight to you guys, which is hindi naman ano, no? So super important, pero it's worth noting lang din, no, is that if you look at the yung ano natin, yung defining contrast, which is in this case ang defining contrast natin is I is equal to ABC, tama? Yun yung for this example ito fractional 2 to the 3 minus 1. Ang ginamit nating defining contrast was I is equal to ABC. And you'll actually notice na si I is equal to ABC. 'Di ba sa dun sa slides na pinakita ko naka-ano tayo parang L1 equals 0 tapos ay L na pala to, no, kasi L equals 0 tsaka L equals 1 yung I'm sorry. L equals 1 yung settings natin. So ito yung magde-determine ng groups. So actually if you notice uh, parang ganun na din nangyayari dito, no. So if you notice look at the defining contrast which is ABC. Yung sa ABC dito naka 1 siya lahat. So that is saying na parang L equals 1 siya. Tapos dito naka L ABC is equal to -1. So parang L equals 0 siya dito. Okay? So it's a different approach pero it still gives you the same na results, no. Yung L approach, yung naka-assign tayo ng L values. Okay? And we can also notice it here. So ang defining contrast natin was ABD and ACE. So if you were to create, let's just create two additional na columns, ABD tsaka ACE. This is A times B times D. And if you drag it down, tsaka A times C times E. Also drag it down. You'll notice a pattern, no? So ito yung ano natin. Kumbaga, if you remember, pagka meron tayong 4 groups, ang kailangan is 2 defining contrast and pwede tayo mag-set ng 2 L's, no? So L1 is equal to 0, L1 is equal to 1, L1 is equal to 0, L2 is equal to 0, tapos meron tayong L1 is equal to 1, L2 equals 0, tapos meron tayong L1 equals 0, tapos L2 equals 1, and lastly, yung both L1 equals 1 and L2 equals 1. Parang ganyan, no? So you'll notice na ganun yung situation dito, no? Ito yung both L1 and L2 is equal to 1. Ito, this is where L1 is equal to, if we just randomly assign, no? Kunwari L1 to at L2 to. Then L1 is equal to 1, L2 is equal to 0. Tapos dito naman, L1 is equal to 0, L2 is equal to 1. And lastly, dito, both L2 is equal to 0. So this is one way to check class, no? Kunwari, uh, you're doing your fractional factorial design, pwede nyo yung i-check actually yung defining contrast nyo. So, create nyo yung columns for the defining contrast. I'm sorry. Tama, defining contrast, and just try to see if dapat if you did it correctly, dapat yung defining contrast nyo should be the same for each block. Kung merong magkaiba dyan, kunwari 1 to dito, tapos biglang -1 dito, meaning baka may something wrong sa ginawa yung equations. No? So you have to double check. Okay? So a question here from Martin, hindi po ba kasama sa ANOVA table yung defining contrast? Minsan, hindi na siya sinasama, no? Kasi dahil sa Sparsity of Fx Principle, pwede mo nang hindi siya isama. Pero dito sa ginawa natin, kasama siya kasi naka-alias naman siya sa, kumbaga, ang defining contrast natin naka-alias sa I, no? Parang ganyan. Or yung parang, naka-low setting lahat. Okay? So, dito sa ANOVA natin dito, in this case, hindi ko na kasi parang sinama lahat sa case na to. Pero if you remember our discussion, you can actually look for all of the pwede niyong hanapin yung mga interactions pa dito. Pero in this particular case, ang ginawa lang natin is yung main effects nung tama ba? Ito ba yung pina-assignment ko? Hindi ko pa ata pina-assignment to. Pero anyway, ang gagawin lang natin dito kasi I mentioned na sobrang daming columns yung kailangan nyo i-create, no? And some of those columns actually are aliased with one another. No? So kunwari, na-determine na natin to na si A is aliased with BD and CE. So hindi nyo na kailangan gawin si BD and CE because already alias siya si A. Tapos B is aliased with AD and ABCE. Aliased again is another term for confounding, no? So hindi nyo na kailangan gawin si ABCE and AD because they are confounded with B, meaning they are indistinguishable from each other. No? So, and because of the sparsity of effects principle, instead of looking at the interactions, titingnan natin yung main effect kasi feel natin main effects parati yung yung merong significant effect rather than the higher order interactions. Okay? So, definitely pag ginawa nyo lahat to, merong mga matitira, no? So we noted na si BC hindi nag-appear anywhere dito. So kaya ginawa natin si BC and there are ilan yung na-compute natin? 10 ata, 10 two-way, tapos 10 three-way din. So it will be an arduous task, no? Kasi hahanapin nyo lahat para ma-complete yung lahat ng kumbaga confounded na mga interactions. So hanapin nyo lahat yun and kung ano yung mga lumabas na unique na hindi confounded with another with any other interactions, yun yung ilalabas nyo siya dito. Pero usually sa exam, if lalabas man dun sa exam, usually ang pinapagawa namin is main factor lang kasi medyo mahirap kasi siyang gawin. Okay? But definitely if you want, kunwari yung study nyo na pinili is parang can make use of this interactions, pwede naman i-employ nyo dun sa magiging case study nyo. No? Okay? Tapos dito sa Taguchi, may isa akong hindi naman. I mentioned parang in passing lang no, kung paano ginagawa um, yung interaction table. Kapag kini-conclude, no, actually someone asked this sa consultation, no, and I think I've answered it. Nakalimutan ko sino. Pero Martin asked, kapag kino-conclude, same po ba ng conclusion yun sa aliases? So again, when we do this aliasing, no, and confounding, parang sinasabi kasi natin na we cannot distinguish between the effects of A, B, D, and CE. So parang sinasabi natin na it could either be si A is significant, si BD yung significant, or si CE yung significant, or all of them are significant. So hindi natin alam kung sino sa kanila yung significant. Kasi again, confounded sila or alias sila with each other. Okay? So we do not know if that variation was caused by the main effect or was caused uh, by the interactions. Kunwari in this particular case, BD or CE. So what the sparsity of Fx principle states that, but because of the sparsity of Fx principle, we can say na hindi siguro dahil dito sa BD and CE. Most likely dahil sa A yun. So ganun natin siya tinitingnan. So we know that by design, sa fractional factorial design, by design, A is always confounded or aliased with BD and CE. But because of the sparsity of effects principle, we can say with some confidence na the variation, the significant effect is the main effect A and not BD and CE. Okay? So ganun natin siya tinitingnan. Ay, si pala, Martin din pala nagtanong. Okay? So sana nalinawan kayo sa paggamit ng aliasing. So in your case, parang a good rule of thumb is always just parang analyze the main effects, no? Parang main effects, tingnan kung significant ba siya or non-significant, unless the problem specifically says na titingnan nyo yung certain certain na interactions, no? And for example, if we really need certain interactions, then we just do the table of signs for those interactions, no? Kasi makukuha rin naman natin yung results na gusto natin. So using just simple yung ano, no, sum if na formula natin. So parang sum if nandito ata, may nag-sum if ata ako dito. Hindi. Ito. Parang pwede ka mag-sum if dito na. So if you have a parang response dito, pwedeng gawin natin is yung isa-sum if natin yung um, values na if oh no, sorry, not sum if. Ang gagawin natin is sum product, tama? So pagka lumabas yung letter niya, or kung naka-high setting yung particular na factor niya doon sa column na yon, magiging positive siya, tapos pagka naka-low setting magiging negative siya. So kumbaga magkano ka lang plus minus doon sa response. So sum product yung relevant formula nun. So if you have the contrast, you can compute for the sum of squares. Parang ganun. Okay? So um let's move on to Taguchi. No? So I've mentioned na sa Taguchi, you can also look at the interaction effects. Pero usually, ang tinitingnan lang natin yung main factors. So some designs actually allow for the computation of Taguchi na or computation for interactions. No, unfortunately, etong ano pala no, etong L8 design. This is an L8 design, I think, or L9. L9 designs, itong sa homework natin, itong homework. Okay, ito. Sa L9 designs do not have a interaction, no? Interaction table. Pero L8 designs, this is an L8 design, does have an interaction table. So I think we can do this example dito, no? So sa L8. So an interaction table looks something like this. Let me. So you can search this in the internet lang. Tapos hanapin nyo lang siya. Just search for interaction tables, Taguchi interaction tables, and you will come up with something like a itong array na to, no? Parang ganito siya. So how you read this is parang we are saying na for example L8 has a 2 to the 7 na design, no? Tapos ang tinitingnan natin is meron tayong 7 columns or 7 factors. So that 7 factors in this case is A, B, C, D, E, F, and G. So sometimes, kunwari lang, you are interested in the interaction of A, B, pero hindi kayo interested sa interaction, sa main effect E. So let's just say ganun yung case, no? So what actually happens in interaction table is that ang nangyayari is you sacrifice a column. So for example, pwede ko i-sacrifice tong column E na to, tapos papalitan ko ng interaction AB. Pero hindi siya as simple as parang papalitan ko to ng AB, no? Parang ganyan. Hindi siya as simple as ganyan. Gagawin natin is, because the Taguchi designs are orthogonal arrays, no? Yun yung term na ginagamit sa orthogonal array. So there are specific na locations, kumbaga, or combinations ng columns natin para masabi natin na andun yung interaction na yun. So let's just say ano, no, we want AB. So AB is in this particular case, kung kunwari AB yung gagawin natin. So AB is in column 1 and column 2. So dapat si AB dito, column 1, the way we read interaction tables is, this is column 1, tapos column 2. So 1 and 2, dapat ang interaction nila should be placed in column 3. Ganun natin sinasabi. So 1, 2, tapos hanapin nyo lang dito. No? So 1 and 2, tapos column 3 dapat siya. So dapat ipapalit natin si AB dito. Okay? Then pwede nang depende kung ano, no, kunwari lang naka-assign na kasi generally speaking dapat arbitrary lang tong mga columns na to, no, etong assignment niya of the factors. Kasi kunwari meron tayong 6 factors instead of 7, then i-assign natin siya sa A to F. Hindi natin kailangan i-assign sa G. So pwede technically natin ano lang, no, iusog lang A, B, C, C, D, E, and F. Parang ganyan. Hanggang F natin. Pero kunwari lang na from the start of the experiment na assign nyo na si A to G to a certain factor, tapos ayaw nyo malito kayo. So pwede naman ang gawin natin is, kunwari lang F talaga yung ayaw natin isama. So, ang mangyayari is mag-move forward lang to, no? So, kunwari magiging C, D, E, and G. Parang ganyan. Okay? So, ganun ginagawa si interaction table, no? So, in this case, whatever we solve for factor AB, uh, doon sa SS, definitely mag-a-adjust tong class, no? Or tama. Whatever we solve for this column, yun yung magiging parang conclusion niya for that particular na design. No? Definitely, it's not to say na you can do this no after the fact. Kailangan gawin nyo siya before. So hindi pwedeng kunwari ang ginawa ko is ito na yung result. Tapos ang ginawa ko is inusog ko lang yung A, B, C, D, E, F, and G. Tapos ito yung same result na gagamitin ko. Hindi pwede yun. Kasi kumbaga, i-adjust mo eh. Kumbaga yung itong treatment combination na to, nag-iba na kasi yung column C. So, posibleng iba na yung setting niya. So, posibleng iba din yung magiging result dito. So, kumbaga, gagawin nyo muna to, itong pag-assign ng whatever interactions na interested kayo. Tas tsaka nyo gagawin yung experiment para makapag-produce ka ng results. Hindi yung gagawin nyo muna yung Taguchi design, tapos after ginawa nyo siya, tapos may result na kayo, tsaka kayo gagawa ng itong interaction table. So hindi mag-work yun pag ganun yung ginawa nyo. Okay? So let's just say again, we are also interested in, let's say, AC. Kunwari, gusto din natin yung interaction with AC. No? So ang gagawin natin is, that's column 1, si A, and C is now in column 4. Tama? So C is in column 4. Therefore, 1 and 4 should be placed in column 5. Tama? Ito yung intersection table natin. So 1, 4 should be placed in column 5. Ang gagawin natin is, so column 5, 1, 2, 3, 4, 5. This is where AC should be. Okay? Tapos uusog lang. Tapos sabihin natin na ayaw natin yung D, no? So sakto lang. So let's just say ayaw natin si G. So mangyayari is D and E lang to. Okay? So again, arbitrary lang kasi yung assignment ng letters. So it doesn't really matter that much, no? Yung sa main effects natin. Pero definitely what matters is, kaya ang ginawa dito is by numbers niya. So we could argue na dapat para hindi nakakalito to interaction table, dapat ang ginawa na lang nila is by letters, no, para hindi tayo malito. Pero since again arbitrary lang kasi yon, mas appropriate na gamitin nila is column numbers na lang para mas hindi tayo malito, no. Okay? So ganun si interaction tables. Then dito, kumbaga ang gusto ko makuha nyo dito sa interaction tables is that you are actually sacrificing, no, na certain columns. So if you notice dito, nag-sacrifice tayo ng 2 columns para i-dedicate sa isang interaction column. Okay? So meaning we can no longer get the parang two main effects para makapagdagdag tayo ng two-way interactions. Okay? Martin asked, yung paggamit ng intersection table, kung ano lang po yung interactions na require ng problem. Yes, parang ganun siya. So if the problem requires na, kunwari, it requires only 5 main effects, tapos hindi niya, pero required niya ng 2 interactions, specifically yung interaction ng factor A and factor B, as well as interaction ng factor A and factor C, then ganito yung gagawin nyo. Parang uh, kailangan nyo mag-sacrifice ng certain columns. Okay? So, usually naman in the exam, hindi kami nagpapa-interaction table, no? Pero again, itong idea na to, you can use it uh, in your studies, no? Kasi kunwari lang sa studies nyo, you see na mataas talagang chance na yung interaction with A and B, kunwari na factor, has a strong influence on your response and gusto nyo makita kung gusto nyo ma-analyze siya, then it helps to do interaction tables, no, para and there are certain factors kunwari na hindi masyadong important sa inyo, then you can sacrifice those columns for those factors para mabuo nyo tong interaction table na to. Okay? Okay, so yun yung interaction. And again, not all interaction, not all designs actually have a interaction table. Only certain designs have an interaction table, and I can show you ito, just a snippet lang to, no. Uh, to So this is example. This is taken from the Minitab website. No? So it's Minitab kasi actually Minitab is one of the softwares you can use para ma-analyze tong uh, it has a whole set of different statistical analysis. No? So and Taguchi is one of them. So this is an interaction table for L8 2 to the 7. Ito naman for L16 2 to the 15. Tapos ito, L27, 3 to the 13. Meron din tayong L32, so on. And you'll notice na, yan. So you'll notice na kung L32, again, yung 32 is the number of factors, di ba? So pagka 32, that is the number of columns na meron tayo dito. Tama? Tapos the number of rows will always be number of columns minus 1 because syempre pagka gumawa kayo ng interaction table, then therefore one less na agad kayo. So if you do one interaction table, mababawasan kayo. So hindi na kailangan yung 16 kumbaga. Ganun, if that makes sense. No? Pero you don't need to worry about that. So these are just examples of interaction tables and you can use them whenever whenever necessary. No? Okay. So now that is um, generally pagka dito sa kasi sa triple ME14 usually in-split natin yung yung Taguchi design into two parts, yung parang loosely sinasabi namin na Taguchi part 1 yung isa, tas Taguchi part 2 yung second. So pero in the remote learning setup, parang ang ginawa is instead of splitting the two, parang pinagsama na lang siya sa isang module, no? So Taguchi 1 and Taguchi 2 is combined into one module. And today ang i-discuss natin is actually Taguchi 2, no? So Taguchi 1 was mostly just trying to figure out kung ano yung no, kung ano yung parang significant factors doon sa ina-analyze natin na problems. Okay, so which is similar sa mga previously na nagawa na natin na ANOVA at 2 to the K design. So we want to know which factors significantly affect the response variable. Okay, so that's good, no? Pero Taguchi is a very, very versatile design, no? Bukod dun sa pag-analyze kung ano yung significant factors, kaya din niya mag-analyze kaya din niyang mag-optimize ng design to reduce variability, no? So that is one of the advantages of your Taguchi design. And to do that, we need to use Taguchi 2, no? And by the way, if you research this internet, hindi nila tinatawag as Taguchi 1 and Taguchi 2 siya, no? So baka hindi nyo siya mahanap if you try to Google it. Pero that's just how we label things dito sa department to. Sa MET-E14 and Triple ME14. Okay? So sa Taguchi 2 is all about optimization, no? So the way we optimize it, we use what we call as a signal to noise ratio. Okay? And wait lang class ah. Ba't walang lumalabas? Yan. Meron ng nasa screen, no? Kita na yung PowerPoint. Okay, thank you for the thank you for the feedback. Okay, so again, ang goal natin is gusto natin 'di ba fast improvement kahit hindi 100% as long as we achieve the improvement in a shorter amount of time. Okay? So, the way we do optimization in Taguchi is actually through yung tinatawag na signal to noise ratio, no? So, this is an analysis of the signal to noise ratio. Okay? So, you probably heard of this term before. Signal to noise ratio it can be applied in many in many industries or many applications. Basically what signal to noise ratio means is that This is a signal is yung parang detectable na parang measurement. So we want to a signal is the detectable measurement, while noise is, as the name implies, para siyang background na ano no na parang measurements that is inherent to the measuring device. So pwede siyang in terms of statistics, kung in terms of statistics para siyang siya yung error no, parang ganun. Yun yung para may background error ka na nade-detect ng statistical analysis mo. Tapos si signal mo is yung nade-detect mo due to how you designed your experiment. Okay? That's for statistics, no? But signal to noise can also be applied for any measuring device. For example, if you are looking at kunwari a chemical analysis kunwari. So have you heard of ano bang familiar kayo na chemical analysis? Siguro XRD or um, AAS. Pico, ito yung pinaka-common example siguro sa min proc tsaka extractive met. So AAS. So for example sa AAS, pwede kang magkaroon ng, di ba pag nagtatry tayo mag-detect ng element, may certain na parang ano, parang energy levels lang tayong tinitingnan. So, yun yung hinahanap ng measuring device natin. Yun yung signal na hinahanap niya. Pero syempre, dahil yung measuring device naman natin hindi perfect, meron tayong may mapipick up na parang background na parang measurements. And that background measurements is our noise. So, for us to increase yung parang detectability natin doon sa in terms of the device, no? Parang para ma-increase natin siya, kailangan we should get as high a signal as possible with little to noise as possible. So parang tataasan, kung mas mataas yung signal to noise ratio natin, ibig sabihin mas maganda yung nade-detect natin na ano no na na parang measurement. Okay? So as applied to parang ganito siya no. This is how a signal to noise if we were if this were a measuring device. Tapos ito yung expected na signal natin na gusto natin i ano i i-detect. Tapos parang you can have background patterns like this. Ito yung noise na makukuha natin. So that is inherent to the device. Kunwari lang may um, parang siguro the best way to explain this is yung pinaka-common no. Parang microphone no. So sa microphone yung setting is yung gusto niya makuha yung voice mo. Parang ganyan. Pero yung background noise is yung kung may electric fan ka sa ano or sa background or kung merong mga sumisigaw or merong mga vehicles passing by, so yun yung background noise. So yung background noise, if combined si signal and the background noise, parang ganito yung itsura niya. So you can roughly say, look at where the signal is, no? Parang ito pa rin yung signal natin. Pero the clearer the distinction between signal and noise is, the better the parang resulting na parang signal na wave natin. So kailangan signal to noise ratio should be kept to a maximum. Okay? So meaning noise should be kept to a minimum para yung signal to noise ratio natin is maximum. So in Taguchi design, for optimization to work, kailangan taasan natin tong signal to noise ratio na to. Okay? Or baliktad no. So in Taguchi design, for you to be able to say na yung isang factor is has a significant effect on the variability of a process, dapat yung signal to noise ratio niya mataas. So meaning parang ang sinasabi dito is if you have a high signal to noise ratio, you are saying na yung factor na yon na ina-analyze mo significantly affects the variability uh, of your of your process no or whatever you're trying to analyze. Kasi konting adjustment mo lang, sobrang taas ng signal na nakukuha mo as opposed to the noise that it generates. Okay? So I hope that makes sense, no? And if it still doesn't make sense, just try to read your modules again, tapos try to analyze it. Pero basically, that is what signal to noise ratio is saying, no? So let's try to do signal to noise ratio in our example, tapos tingnan natin kung ano yung makukuha nating results. Okay? So we'll define two terms dito before we proceed. No? Meron tayong tinatawag na control factor, tapos meron tayong tinatawag na signal factor. So, pag sinabing control factor, ito yung factors that may or may not may or may not affect the process mean or the response variable, pero they significantly affect the variability of the process. Okay? So again, I mentioned na si Taguchi design is mostly used for ano no, mga processes kasi siya as opposed to yung parang nag-analyze lang kayo na which factors affects which response variables. Usually as applied to yung industry processes to. Okay? So bukod dun sa pag-analyze kung gusto ba natin kung gusto natin makita kung aling factors ang nakaka-affect sa process mean or sa yung response variable natin, gusto din natin malaman kung ano yung nakaka-affect dun sa variability na yun. Kasi if you're doing a certain process, gusto mo as much as possible maliit yung variability. Let's just say na nagpo-produce kayo ng um, ano ba magandang i-produce. Kunwari nagme-metal rolling kayo, no? So nagpo-produce kayo ng metal sheets. So gusto mo as much as possible maliit yung variability doon sa ano mo sa parang final, let's just say ang process mean natin or response variable is the thickness of the sheet. So if you were a manufacturer for that particular process, gusto mo na i-minimize yung variability doon sa thickness ng sheet natin sa metal sheet. So the way we control that is through the control factors. And later I'll show you how you can determine which is a control factor and which is a signal factor. No? Okay, so again, doon sa metal sheet example, bukod doon sa pag-analyze kung ano yung nakaka-affect doon sa thickness ng sheet natin. So this could be either mga roll gap, this could be the roll diameter, this could also be yung parang working temperature, parang ganun. There could be many factors that can affect the thickness, pero those factors could also affect variability of the thickness. So pwedeng kunwari hindi significantly nakaka-affect sa response variable yung isang factor, pero yung adjustment mo of that factor can affect yung variability niya. So pwedeng kunwari at higher settings ng temperature, kunwari at higher temperature usually mas malaki yung laro ng ano natin ng thickness. Kunwari usually 10 plus minus 2 yung napoproduce ko, pero pag mataas na temperature naging 10 plus minus 5 siya, parang ganun. So those are control factors. So certain settings can produce minimum variability. Okay? Yung signal factors naman, ito yung usual lang natin, yung ina-analyze pagka nagka-ANOVA tayo. Ito yung nag-i-influence sa process mean. So process mean being again yung response variable natin, pero hindi necessarily na nakaka-affect siya sa variability, no. It can sometimes a signal factor can also be a control factor, no. So and this now depends on you whether you want to control the factor as a control factor or kung gusto niyo maging signal factor siya. And this comes with experience, no? Pero usually, if it's a signal, it's a signal factor, usually ginagawa natin siyang signal factor. Pag non-signal factor lang siya, ito yung mga not significant, yung lumabas sa ANOVA natin. Pag not significant siya, tsaka lang natin siya tingnan as a control factor, no? So, again, si signal factor, since ito yung heavily nag-i-influence sa process mean natin or sa response variable. So, parang doon sa example ko na metal sheet, no? Ang signal factor would be something that kunwari, ang napoproduce mo is 10 plus minus 5. So, yun yung variable na yung variation niya. 10 plus minus 5. Ang ginagawa ng signal factor, let's just say roll gap yung binabago natin, no? So adjusting the roll gap actually changes the process mean. So for example, from 10 plus minus 5 nagiging 8 plus minus 5 siya. So bumaba yung parang process mean natin or response variable natin. So yun yung ano natin, signal factor. Directly ina-affect niya yung ano natin, yung signal factor, yung process mean. Okay? So usually ginagamit natin ang signal factor to adjust the centering of the process mean. Centering meaning kung ano saan mo gustong location generally, no? Location ng process mean natin, whether you want it to be at kunwari may target kayo na na response variable or process mean, no? So you could have yung parang may target kayo na kunwari 10 or pwede rin ang target nyo is as high as possible or pwede ang target nyo is as low as possible. Okay? So, yun. Yun yung two factors na i-analyze natin for today using Taguchi 2, no? Okay? So, there are three formulas for signal to noise, and we use these formulas depending on the application, no? So, meron tayong tinatawag na smaller is better. So, this is a case wherein doon sa response variable, gusto natin na mababa siya. So, what do we mean by this? So, let's just say na we are doing a process, no? Tapos, ang response variable na tinitingnan natin sa certain process na yun is we are looking at number of defects. Okay? So, kung number of defects siya, in that particular scenario, smaller is better. Tama? If you have smaller number of defects, then your process is better, no? Okay? So, if the smaller is better siya, ito yung formula na gagamitin natin. So just take note of the formula and I'll just copy paste na lang ito mamaya, no, para mas maalala natin. Okay? So it's just negative 10 log 1 over n times summation of yi squared. Okay? Tapos, we also have a larger is better formula. So larger is better formula is usually para sa mga settings na wala tayong target pero gusto natin as high as possible siya. So let's just say gusto natin mag-produce ng ano, no, parang let's just say metal rebars kunwari. Tapos gusto natin yung rebar na yon is gusto natin sa process natin nakakapag-produce siya ng strong material. So doesn't matter kung ano yung strength niya, basta makapag-produce tayo based on that machine or that process, gusto natin as high as possible yung strength na lumalabas doon. So pagka ganun, larger is better yung gagamitin nating SN formula when we calculate, no? Because for that particular scenario, when the response is larger, you have a better process. Okay? And lastly is yung nominal is best. So ito yung cases wherein hindi necessary na small value yung hinahanap nyo, hindi rin necessary na large value yung hinahanap. May particular value kayong tina-target. Okay? So this occurs when you have a target value, no, or a nominal value. And a perfect example would be, and this is an actual example na kunwari doon sa batteries kasi lead acid batteries. And again, this is my example because I used to work in Motolite, no. So sa Motolite, usually yung mga may tinatawag kaming lead grids, no, which is inside the battery. Yung lead grids, it should contain a particular na tin content. Parang 1.5 ata yung tin content nun. So, anything higher than 1.5, parang pangit yung magiging result niya. Parang pangit yung magiging performance ng battery. Tapos anything lower will also produce a poor performing battery. So, meron lang sweet spot kung saan good or best yung performance ng isang lead acid battery if you have the right amount of tin. So, in that particular case, nominal is best kasi may target value tayo na gusto. Okay? So, that is what you should think about, no? Whenever you use Taguchi 2, always look at the problem. Tas, first thing that should come into your mind is, ano ba yung treatment ko doon sa response variable? Is it nominal is best? Is it larger is the better? Or is it smaller the better? Okay? Yun yung una niyang titingnan. And later, I'll give you an example. Tapos, let's try to look at it, no? Kung ano yung particular scenario na yan. Okay? So let's just say ito yung example natin. Meron tayong manufacturer of resistors and we want to improve yield on the substrate chips, many of which have been rejected for thickness problems. So may tolerance siya na 20 plus 4 and they decided to run an experimental design based on these following factors. Meron tayong 4 factors now with 3 levels each. So yung appropriate na nito na design is the L9 design. L9 3 to the 4. We have 4 factors, 3 levels each. Tapos ito yung kunwari nakuha nating results, no? And I think this is the same tama ba? This is the same result doon sa pina-homework ko. Actually, same result siya. About 27, 31, 28. Sakto 27, 31, 28. Okay? So maganda to kasi at least we already have the data now. Okay. So eto siya. Ah, gusto natin na wants to improve yield on substrate, many of which have been rejected for thickness problems. Okay, so dito medyo confusing yung problem, no? The problem was designed para di straightforward yung malalaman kung nominal is best ba siya, higher is better, or lower is better. Okay, so if you look at it, parang um, you could argue na parang lower is better siya because it talks about rejection problems. You could also argue na it's a nominal is best kasi may mention siyang tolerance. So may target siya, kumbaga 20. So that is a ano no, nominal is best. Tapos pwede din i-argue na gusto daw niyang i-improve yung yield ng substrate chips, which is a higher is better problem. So dito kailangan natin i-check yung language mismo, no? So what is the goal? The goal is uh, so ang goal natin is to improve yield by um, making it such that yung napoproduce natin na product is within this range. Tama? So ulit ko yung sinabi ko, no? So ang specific problem kasi na to, ang parang sinasabi niya is dahil merong mga products na hindi pumapasok sa range na to, merong mga nare-reject and therefore bumababa yung yield nila. Yield meaning kung ano yung usable chips na pwede nilang i-send out, no? I-send out, no? Okay? So, if that's the case, kung ganun yung scenario, tingin nyo ano yung case na to? Is it nominal is best, higher is better, or lower is better? And our response here is, parang mas lang Sorry. Ang response variable natin dito is actually, ang response variable natin is the thickness, no? Okay? Some have, merong nag-submit ng correct answer, no? So actually, tama, no? This is a nominal is best na problem kasi gusto natin na i-target tong 20 para hindi tayo magkakaroon ng rejections due to thickness problems. So we want the response variable, and if you look at this, this is our response, no, yung thickness. Gusto natin yung thickness na to should be somewhere around 20. Okay? So we talk about control and control and signal factor. So in this particular case, parang signal factor would be such that etong thickness na to, ita-target niya instead of being 27, 31, 20, these are exact high values. No, gusto niyang uh, i i-adjust yung by adjusting a particular factor, gusto niyang babaan tong thickness na to para ma-reach yung 20. That is signal factors, no? So ang signal factor siya yung ina-adjust natin para ma-reach yung target na value. Okay? Pag sinabi namang control factor, siya yung nagre-reduce ng variations ng ano natin. So for example, ito 27, 31, 28 for the same settings, ganito yung naging variation niya. So you'll have to do statistical analysis, no, para to determine it. Pero just by looking at it, parang 27, 31 and 28 medyo okay naman. This is an example of high variability, no? 19, 14 and 21. If you look at it, parang same settings, 1, 3, 3, 3 siya na setting. And you can see na it's all over the place, no? Minsan 19 siya, minsan 14, minsan 21. So, yung control factor, parang sinasabi niya, gusto niyang iiwasan itong mga ganito, no? Nire-reduce niya yung variability na to. Okay? So, the way we do it is, balik tayo sa Excel natin. Tapos, start tayo ng new. And we can use this same, copy natin to. Kasi ito yung, natin. Okay? I-adjust ko lang. Book. Mali. Ayan. So, I'll start with a new book. Okay? So, may factor settings natin. Ito yung results. Ito yung total. Okay? So, the first thing we do is, yung regular lang muna. Actually, ginawa na pala natin to. Pero sige. Gawin lang natin ulit. Okay? So, para lang makita natin siya ulit in action. No? So, first, gawa tayo ng response table. We have 1, 2, 3. Tapos, gawin natin is sum if itong array na to is equal to this one and we sum the total. Tama? Tapos, gawin natin is F4. Fix natin yung total. Tapos, itong criteria, gusto natin mag-move siya up and down but not left to right. So, i-fix natin yung column. Tapos, ito, si sum if gusto natin mag-move left to right but not up and down. No? So, yung number naman yung i-ano natin or the row. Okay? And just to double check, tama naman. Okay? So, ito yung sum, ano natin, parang response table natin. Ngayon, i-compute naman natin yung SS natin. So, to compute SS, we need SCF, no? Or yung correction factor natin, which is just sum ng total squared divided by count. Ito. Okay? So, over total number of observations. No? Okay? So, again, pwede kong ang gawin is sum nito or sum nito. It doesn't really matter, no? Kasi yung grand total will just be the sum of either this one or this one. Okay? So, yan yung correction factor natin. Now, we can compute for SS now, which is just sum square nito. And again, divisor natin is how many individual data points came together para mabuo tong values na to. So, this 194 came from 3 values, no? Because parang ano siya, itong 1, 2, 3. So, 3 individual subtotals, but each subtotal came from 3 replicates. So, over 9 siya. Tama? Over 9 minus the correction factor and lalagyan natin ng F4 si correction factor para pwede ako mag-drag to the right. Okay, so if I drag this to the right, I should get the SS values no, for the different A, B, C, and D. Okay? Now, dito sa response natin, we can now set up, we can set up a separate table. Ito, response table. Let's call this response table as averages. No? Okay? So, the way we do this is just do, baka mas maganda kung dito ko ilagay. Hindi, dito na lang sa tabi. So, ang response table for averages is just, and let me add na lang ako ng isa pang ano, no? A, B, oh, nangyari. Ba't hindi ako makakatype? Ala, ano nangyayari? Sakit lang class ah. Save ko lang muna to. Mukhang nasira yung file. E10. Sakit lang class ah. Save ko lang. Tapos reopen ko na lang. Okay. Umayos na siya. So, this is A, B, C, and D. So, ganito. Later, realize kung bakit ko siya ginawang ganito, no, para mas makita natin. So, ang gagawin lang natin is we just take this divided by 9, no? If you take that, then you should get the average, no? So, again, 194 came from 9 values. So, the average of those 9 values will be 21.556. And ito, pwede ko lang i-drag, ganyan. So, okay, so we have ito yung signal na settings natin, no? So let's just call it a signal settings. So signal settings will be yan ako lang. Or better yet, move ko na lang to the right pa. Okay. So itong signal settings, hindi na pala na maling book. Nakabukas. No. Ayan. Tama na yung book na nakabukas. Hindi, mali pala. Ito, tama na? Ito, tama na. Okay. So yung ito ang ginawa natin, ginawa lang natin klase is dinivide by 9 lang, no? Ito. Tapos dinrag lang natin. So ang ginawa ko is equals ito divided by 9. Tapos sige, purahin ko lang muna. So again, that's equals so divided by 9 because again each individual each subtotal na to comes from 9 individual values. So if you want to get the average of those values, you just divide it by 9. Tapos dinrag ko lang to the right and downwards para makuha to. Okay? So mayroon akong response table which contains the averages, no? Now sa response table for the averages, yung signal settings na pipiliin ko, and this is hindi ko pa alam kung signal factor siya or not, no? Pero pwede na actually ako mag-set ng settings for them. So ang gagawin natin is A3 which is we are doing nominal is best, no? So we choose the setting that is closest to 20 kasi yun yung nominal value natin. Okay? So dito A3 yung signal setting for the A. Tapos dito closest is B2. Tama? Dito which is closer 19, 21. This 1.6, ito 0.8. So therefore C2 yun yung closest setting to 20. Tapos ang last is ito 1.3, 0.7. D3. Yun yung signal settings natin. Pero right now, hindi pa natin alam, no, kung signal factors ba lahat ng to. Pero we can already set kung ano yung settings nila if they were signal values. Okay? So, to continue para lang ma-solve natin kung sino yung signal settings natin, kailangan natin na i-solve yung first, yung Taguchi 1, kumbaga, yung ANOVA table nito. So, to solve the ANOVA table, again, ito, sum square ng lahat ng to. This is sum total SST, no? Minus correction factor, which gives us 568. And ito lang actually yung homework nyo. So medyo preview na to ng homework nyo, kung tama yung ginawa nyo. So we go source, SS, DF, MS, SS, DF, MS. And then we have, label this, no? I'll say ANOVA response. Okay. Tapos, because we'll do 2 ANOVA, no? So this is para mas, no, may analogous siya doon sa Taguchi 1, Taguchi 2 natin. We can also call this as ANOVA 1. just to distinguish it from the next ANOVA na gagawin natin. So we have ANOVA 1, MS, SSDF, MS, and then we have FCalc, and we have p-value, and we can have conclusion dito. Okay. So we're looking at main factors lang, no? And again, si L9 wala actually siyang interaction table. At least not that none that I can find, no. So if you manage to find one, pwede naman gamitin natin. Pero as far as I know, L9 has no interaction table. So main lang siya. So main effects, then we have error, and we have your SST. Okay. So SST natin is this value. Tapos A natin is this one. And again, I'm using dynamic referencing class, no, para just in case may mali ako ginawa dyan somewhere, easily na nag-a-adjust na to lahat. Okay? Ito, minus sum. So I got error. DF natin, this is equal to count. This one, minus 1. 26. Error natin is equal to same siya ng formula. And if you fill out na lang natin, each of the factors has 3 levels. Therefore, 3 minus 1 is 2. So, meron silang, tig 2 degrees of freedom. Okay? Tama ba? Tapos, MS natin, as usual, is just SS over DF. Okay. Diyan. Tapos, FCalc natin is MS ng source natin divided by MS of the error or MSE, which we press F4 para ma-fix natin yan so that I can drag it downwards. Ito. Okay? So ito yung F-calc natin. Now we can solve for p-value. And to solve the p-value is just F this RT, itong X, degree of freedom 1 is this one. Tapos degrees of freedom 2 is the denominator, which is in this case, the MS error or the error. So, that's if i-fix ko para pwede kong i-drag ulit pababa. Okay? So we have 3 values, and from here, you can see na this is not significant. This is significant, this is significant, and this is also significant. Okay? So from here, pwede ko nang masabi na, and I'll just do it. I'll just highlight this or make it bold, no? Na ito yung mga signal factors ko, and for me to get the nominalist best setting for these 3 signal factors, dapat naka B2 siya, naka C2, and naka D3 para makuha ko yung 20. So A3, we'll have to check sa signal to noise ratio natin, no? But A3 can be a control factor. Right now, si A3 is just saying na regardless kung ano yung piliin nating settings for A3, it wouldn't affect the response variable kasi wala siyang significant effect. So if, for example, if this were, ano ba ito yung A3 na setting natin? A setting is, balikan natin yung problem. So let's just say na tumigil tayo dito, no? So if we were to do this, the setting A is ito, no? Factor is ceramic material, so it could be paraffin, paste, or mixture, and we know that based on the signal factors, wala daw effect siya. So kung tumigil tayo dito, let's just say hindi na tayo nag-signal to noise, no? Kung tumigil tayo dito, then the good engineering decision would be check mo yung prices nito. Ano yung pinakamura? Kasi alam naman natin na hindi siya nag-make ng difference, di ba? Based on the signal factors, hindi siya nakaka-affect doon sa response variable natin. So we can choose whatever is the cheapest option. So if paste is cheaper than paraffin, then we can just use paste, no? Instead of paraffin. And definitely, itong mixture kasi is a mixture of paraffin and paste. And definitely, mas makakatipid tayo kung paste yung ginamit natin. Okay? Pero let's check, no? If yung nakuha nating if pag nag-signal to noise tayo, baka kasi itong ceramic material is a control variable or control factor. Okay? So, balik tayo dun sa Excel natin. Okay. Tapos kukunin ko lang yung ano natin, no? Let me get the signal to noise ng nominal is best. Hanapin na saan yung formula na yun. Okay. Open ko lang to. Lagay ko sa ano natin. Laki nito. So ito yung formula natin. Ito. Okay. Para guided lang tayo. So gagawin natin is we actually create a new column dito, no? We call it as the SN ratio column. Tapos isosolve natin per treatment combination. Magsosolve tayo ng signal to noise ratio. Okay? So, before that, you can also, ano dito class, no? You can actually compute for the percent contribution as well. So, pwede tayo mag-compute ng SS prime muna, tapos percent contribution. Percent P. Parang percent P yung name, no? So, SS prime is equal to, or the pure SS, no? This is equal to, ito, minus DF times MSE. And do F4. Tama ba? I'll just double check class lang kung tama yung formula ko. Tama naman yata. So, drag it down. Okay. So, ito yung pure natin. And yung pure SS sum of squares ng error is just equal to ito minus yung sum nitong mga pure values, no? Okay? So, you have your pure SS prime, and from the pure SS prime, you can now compute for yung percentage, no, contribution. So, ito times 100, or pwedeng ganito na lang. Drag kita. Sorry. You need to fix F4 para pag dinrag down ko, siyang babago. And I could just adjust this and make it as a percentage. So, Excel has a function na pwede mong pindutin lang tong button na to, and automatic ko-convert into percentages. Okay? Pwede siguro kahit 1 decimal place. Okay? So, ito yung percent contribution niya. 1% can be attributed to A, which makes sense, no? It has a low percent contribution kasi hindi siya significant. Tapos, 54% can be attributed to B, which is a very large number, no? Tapos, 12% attributed to factor C, another 12 from factor D, and yung error natin comprises 20% contribution. Doon sa assignment, Martin asked if need yung percent contribution. Yes, the percent contribution is needed, no? Pero if you didn't, if you've already submitted tas hindi nyo ginawa tong percent contribution, okay lang din naman. I'll accept it, no? Pero percent contributions is ano, no, is part of Taguchi 1, or yung first na part. Although doon sa problem naman na binigay ko, hindi ko naman sinabi na, sabi ko lang na identify which um, factors are significant. So okay lang kahit hindi niyo siya ginawa, no? Pero this is additional information that is part of Taguchi 1. So you can do it if you had the time. Okay? So 26 saan tayo? Okay? So ito, ang gawin na natin ngayon is yung signal to noise para ma-compute natin um, yung control settings natin kung baga, no? Okay? So if we did this, we do ito. Let's use this formula. And para ma-solve natin to, we need actually an additional table pa, no? SM and VE. Hindi ko actually alam kung anong meaning ng S sub M and V sub E, no? So ito, S sub M is just yung summation ng mga individual y values niya, and we just square that values and divide it by the the total. So we just do sum of ito. We use the etong individual data points as opposed to the total. Actually, pwede palang total lang gawin natin kasi sum naman yung formula. So pwedeng sum nitong tatlong to, or pwede rin gawin natin is equals ito kasi nakasum naman na to. So sum nito squared divided by we have 3 individual values, no? So divided by 3. So number of replicates. Same. Tapos drag it down. Tapos V sub E natin is just summation ng y squared minus SM. So that's equal to we do sum squared. Tama? Kasi summation ng squared values ng individual na data points. So that's sum squared nito minus SM, which is this one. And kailangan din ito ilagay sa parenthesis divided by n minus 1. And n minus 1 here is just 3 minus 1. So that's 2. So divided by 2. Or para mas kasi okay na yan. 2 lang gagawin natin. Okay? So drag it down again. So meron tayong values. Tapos pwede natin i-compute yung SN ratio. No? So SN ratio is equal to 10 times the logarithm, and this is base 10, no? So we use log 10. Log 10. Sa Excel kasi if you just do log, kailangan nyo i-specify yung base, no? So for example, para hindi na tayo magdagdag ng base natin, natin, log 10 na lang gagawin natin. Ang default ata nito, if you don't specify a base, is the natural logarithm ata. But you'll have to check, no? Ang alam ko, ganun eh. Okay, so log 10 yung gagawin natin. Log 10. Tapos, we do 1 over n, which is 1 over 2 multiplied by, gawin ko na lang is, ilagay ko na lang yung n sa baba kasama sa VE. So, pwedeng SM minus VE. That's SM minus VE divided by n, which is 2. 3. Divided by, sige, para baka malito kayo sa ganung notation ko. No? So, 3 times VE, which is, yung VE natin is this value. So, ito class, this is just the same as usually I like to do ganito lang, no? 3 over yung VE. Parang ganyan. Pero sometimes, yung mga estudyante na nalilito kasi sa ganito, no, na parang dire-diretso yung dalawang divided by. Pero basically, MDAS kasi yung sinusunod ni Excel. So, parang ginagawa nito is, itong term na to, dinivide niya by 3, tapos i-divide niya by L3, which is the same lang naman yung makukuhang value. Okay? Pero, for this purpose lang, para lang mas malinaw, no? Since nasa denominator sila lahat, ang gawin ko na lang, close ko in parenthesis, divided by 3 times yan. Okay, that's enclose natin parenthesis sa logarithm, and we have our SN value right here. Okay, and if you drag it down, you'll have your SN values. Okay, now let me double check. Okay, tama naman. Okay, so I now have my SN values. Okay, pwede ko palang tanggalin na lang to, no? Alam nyo naman na ABC dito, no? Para lang mas malinis yung ko. So from these SN values, pwede tayo mag-create ng response table. Let's call this as the SN table. No? So create tayo ng SN table, and the SN table will be, and can I move this to the right? Okay lang. Move downwards ko na lang to. Okay lang. Add na lang tayo ng column. Okay. Let me just move this again to the right. Oop. Yeah. So SN table natin. This is your level 1, level 2, level 3. So gagawin natin is equals sum if yung range na to is equal to this one. Pero ang isasum natin ngayon is yung signal to noise ratio. Okay? Tapos, like what we did before, i-F4 natin to para hindi mag-move to. Yung 1 natin gusto natin up and down, but not left to right. So that's, i-fix natin si column, which is the letter. Tapos dito naman, yung range, itong blue na array na to, gusto natin left to right, but not up and down. So i-fix natin yung row or the numbers. Okay? So yan. Okay? So meron na tayong tables for the SN table, no? So from the SN table, kaya natin mag-set ng control settings. Okay? So dito sa control settings, again, di ba signal to noise ratio is the higher the signal to noise ratio, the more signal you get with the lower amount of parang noise. Tama, no? Kasi gusto natin na mataas yung detection natin as opposed to yung background na measurements. Okay? So dito, para pumili tayo ng appropriate settings, pipiliin natin yung highest signal to noise ratio. Okay, so it doesn't matter kung nominal is best ba siya, higher is better, or lower is better. Once you have already computed the signal to noise ratio, you always get the highest signal to noise na settings, no? Okay, so in this particular case, the highest signal to noise is A2. Tapos dito, highest signal to noise is B2. Tapos dito naman, it's C1. Tama? And lastly, ito is D1. Okay? Okay. So ito yung mga control settings natin. If we were to make these settings as your control variables. So A2, B1, B2, C1, and D1. Okay? So again class, dito madalas nagkakamali yung mga students, no, kasi minsan na may mix up nila yung terms na kunwari higher is better, lower is better, tsaka nominal is best. So for example, ang problem is a lower is better problem. So nag-assume sila na lower is better. So dapat dito sa table pipiliin ko yung lowest signal to noise ratio. Hindi siya ganoon, no? So again, ito is signal to noise na yung na-compute nyo. You will always want to have the highest signal to noise regardless of what situation it is. So, ginagamit lang natin yung mga lower is better, higher is better, and saka nominal is best para lang mahanap natin yung appropriate formula para makuha itong SN ratio na to. So, once we already have the SN ratio, always choose the highest na signal to noise ratio doon sa SN table natin. Okay? So, dito, we will check kung alin yung mga control factors natin, no? Kasi again, hindi necessary na kung signal ka lang, tapos automatic control ka. Tapos hindi rin necessary na kung control ka, automatic hindi ka signal. Posible na both signal and control ka. Tapos it's up to you and as the analyst or as the engineer to choose ano yung gusto mong i-sacrifice, variability ba or yung adjustment of the control process mean. Parang ganun. So later I'll show you. Tapos there are also cases na hindi ka signal setting pero hindi ka rin control setting. Okay? So in that case na parang ang sinasabi natin is hindi siya nagmamatter na factor. Kumbaga, hindi siya significant both as a signal factor and as a control factor. Okay? So let's look at the ANOVA 2. So let's call this ANOVA 2, no? And this time, this is for the SN na ratio. So ANOVA 2, same yung gagawin natin, no? Source. I'll just copy this. Source and hanggang conclusion lang kasi wala namang percent contribution for the signal to noise, no? So we have 4 sources, A, B, C, and D. And we have your error. Tapos SST. Okay? So yung SS total natin, we'll use this column, no? Ito naman yung gagamitin natin ngayon. So it's not the same as, kumbaga i-discard nyo na to, no? Hindi nyo siya, itong 4 columns na to, yung 3 replicates and 1 subtotal, hindi nyo siya gagamitin. Kumbaga iti-treat nyo as if ito yung data nyo sa itong signal to noise ratio. So if that's the case, then the SST should be sum squared nitong values na to, ito. Kasi kumbaga ito yung data points natin. We only have 9 data points in this case, no? Minus yung sum, this sum squared divided by, so that's sum squared divided by count, ito, which is, ano no? Ulitin ko lang, no? 149. Ulitin ko lang para mas malinaw and let me just hide these columns here para mas makita nyo, no? Kasi para hindi ako scroll ng scroll. Hide ko lang muna, tapos i-show lang natin mamaya. So ulitin ko lang para mas malino, no? Equals sum squared nitong values na to, itong signal to noise ratio, minus yung correction factor, and this is not the same correction factor as what we computed earlier, no? So magiging sum, di ba ang correction factor is always the grand total, which is this one, squared divided by count to. Okay? Actually, pwede ko palang i-solve yung CF2, no? Pero anyway, okay lang yun. So ito yung SS ko. Now, what we'll do is we'll also create a parang, ano no? We've already created the response table for the SN, or we already created the SN table. So pwede na natin makuha yung magiging SS niya, no? So from this SN table here, pwede tayo makakuha ng SS actually, tama? So what we do is we sum square nito. Tama kasi sum if na to ng SN natin. So gagawin natin is sum square of of these values, and etong values na to we divide it by yung denominator natin again is how many points did these subtotals come from, no? So itong subtotal na to, itong 55, 71, 65 came from 3 values, tama? From the 3 parang level na settings. Okay? So over 3 siya. And note na hindi siya over 9, no? Kasi again, tinitreat natin to as a single data point. So kunwari itong signal to noise ratio na 22 comes from 1 value lang, signal to noise. Ito kasi computed value to using SM and BE. Tama? So ito 22, 1 point lang to. So 3 dapat yung denominator natin. As opposed to kanina, ginawa natin over 9. Tama? Kasi over 9 siya kasi may 3 replicates. Pero ito, hindi naman to replicated. Kumbaga, signal to noise ratio naman to. So over 3 dapat siya. Okay, so over 3 minus yung correction factor, and let me just ilalagay ko lang yung correction factor dito, no. So I'll just name this as CF2. para hindi tayo malito, no? Sa ito, CF1 na lang to. Correction factor naman natin is grand total sum ng SN ratio na to squared divided by count. Ito. Yan. So, meron na tayong SS value. Tapos, pwede nating i-F4 to para pwedeng i-drag to the right. Okay? So, meron na siyang SS value. So, one thing you'll notice here is, since we treat it as 9 lang yung ano, no? Parang 9 data points lang kayo. Definitely, you'll have to do pooling here because, and I'll show you here, pagka ginawa natin, SS, ito, and again, dynamic referencing ang ginagawa ko para, pag may mali man ako somewhere dyan, easily adjustable siya. So, if you do sum, ito, minus the sum, you'll actually get a zero value, no? Or a negative value. So, this means that kaya siya negative kasi, um, kumbaga, masyadong maliit yung degrees of freedom natin, yung total degrees of freedom because we only have 9 degrees of freedom, no? And hindi siya 27 as opposed to the response na ANOVA kasi again, itong SN ratio na to, this is considered as one data point lang. Okay? So we have only 9 data points, therefore yung ano natin, degrees of freedom natin is only 8. So therefore, kailangan natin mag-pool ng data points, no? So para magawa natin 'yon to uh, and the degrees of freedom of the source is still 2, no? Kasi 3 levels pa rin yung ginawa natin. Kung nung nag-compute tayo ng SN table na to, 3 levels pa rin naman yung ginamit natin. So, the degrees of freedom will be 2, 2, and 2 pa rin to. So, equals sum, sorry. Pwede ko i-drag lang to, no? So, 0 yung degrees of freedom ng error. So, ito negative. So, we can't have that, no? And actually close to zero to. May konting error lang siguro dahil sa ano, pero this should be equal, no? Para ito 149.83. If you look at the total at the bottom, it's 149.83, which is close to this one. So may konting discrepancies lang, no? But essentially this saying na zero tong value na to because this total is just this total right here. Okay? So that's why we need to do pooling, no? So remember, nag-pool din tayo sa previous na examples natin, no? So rule of thumb again is 1/3 to 1/2. So ang target natin is we need to get 1/2 of the degrees of freedom of the total and i-pool natin siya papunta sa error. So in this case, pwedeng dalawa yung ipo-pool natin, no? Yung smallest values. So dito kung compare natin with this is 47, this is 99. Etong dalawa 0 and 2, this is relatively small compared to the other two. Therefore, ito yung ipo-pool natin. So ganyan ko na lang para to indicate na pinull natin siya. And since pinull natin siya, what you can do is para mas mabilis class, no? Kunwari may formula na kayo ganito, what you can do is just delete this, tapos mag-adjust na siya. Pero for illustration purposes, ang gawin ko na lang is i-adjust ko na lang tong size ng table array ko. So this is from minus sum ng, this should be sum nito and ito. Okay? Pero again, if you want to do it faster, pwedeng delete nyo na lang itong values na to. I just like to, kasi ibibigay ko sa inyo to. So para lang makita nyo na pinull ko siya, kaya ko siya ginawang ganyan. Okay? So we can see na ito relatively mataas yung DF, no? But we need to look at the p-value, no? Para to say if it's really a control variable or not. Okay? So MS is this one divided by this one. Yan. So I have MS values. Tapos Fcalc natin is equal to MS over MSE. F4 natin ulit para pwedeng pag kinopy-paste ko siya, ma-fix siya. Okay? So from the MS value, we can have P value is F.this.rt x Degrees of freedom is this one. Degrees of freedom ng error is this one. F4 ulit. And I can drag it down. Tapos delete ko na lang to. So I have two p-values and clearly it's less than 0.05. And again, inassume ko lang na although hindi sinabi ng problem, no? I've mentioned this a bunch of times. Whenever hindi binigay sa inyo um, yung alpha value or level of confidence, just assume it to be 0.05. Yun yung standard natin. Okay, so it's less than 0.05. Therefore, significant siya. Both A and significant. And I can actually pwedeng i-expand ko pa to, no? Not sig, therefore signal factor siya. Pwedeng ganyan yung ano ko. Tapos pwedeng dito significant control factor. Para mas malinaw, no? What I mean by significant in these two cases. Okay na. Okay? So, in this particular case, only A and D are control factors. Therefore, ito siya, A and D. So now, you have the choice, no? Ano yung magiging final setting natin? Definitely, ito for A, B, and C. So, we can do final settings here. So, A is not a signal factor, but it is a control factor. Therefore, is set natin si setting for A as A2. Tapos, si B and C are both signal factors pero hindi sila control factors. Therefore, pipiliin natin yung signal settings nila. So that's B2 and C2. And now you have a choice dito sa D, no? You can opt um to parang use it as a signal factor para ma-reach nyo yung nominal value of 20. So pwedeng ganun. Pero pwede rin i-control or gamitin nyo siya para ma-control nyo yung variation niya. Okay? So, now this comes from experience, no? Kung paano nyo siya i-justify. So, one justification is pwede nyo tingnan dito. You can see na si D has a 12.6% na contribution, no? So, meron siya 12.6 contribution doon sa pag-reach ng nominal target natin of 20. So we can say na hindi siya as important as factor B, no? So factor B has a 54.5% na contribution. So meaning kumbaga si factor B talaga yung nagdadala para ma-reach nyo yung nominal target of 20. Okay? So pwede kong i-argue na kung gusto ko na parang mas controlled yung process ko, less likely less variable siya, pwedeng i-choose ko na lang I can opt to have D as a control variable. So I'll choose D1 para ma-control ko siya and I'll just use B2 and C2 to reach my target. Okay? And I can do this because si B2 kasi I know that B has a very high na percent contribution, 54.5% in fact. So meaning parang I can bank on the fact na by adjusting B2 to a level that is optimal, then I can reach the target settings or the target process mean. Tapos si D1 is now used for control, pang-control na lang. Pero again, this is more ano na to, no, based on experience na lang. If for example lang ang nangyari class, no, is kunwari factor B is both a control and a let's just say si factor B is both a control setting tapos siya din ay isang signal setting. So if that's the case, definitely hindi nyo pwedeng gawing control setting si B, no, because it has a huge contribution doon sa signal natin or huge contribution doon sa response variable natin. Okay? So in that sense, parang mas appropriate na gawin natin siyang signal settings as opposed to a control settings. Okay? So, doon lang siguro siya magiging complicated, no? Yung parang pag-analyze nyo kung appropriate ba na gawing signal setting yung yung isang factor or gawin nating control setting siya. Okay? Pero definitely for these cases etong A to C, no, signal setting si dito based dito, signal setting si uh, B and C pero hindi sila control factor. So wala naman kayong choice. Gawin natin signal, pipiliin natin yung signal settings nila. Tapos ito naman si control, si factor A, hindi siya signal factor pero control factor siya based on ANOVA 2. Okay? Therefore, wala naman kayong choice. You need to choose its control setting. So A2 siya. Okay? So yung final settings natin will be this one. And if you want, you can also have yung A natin should be, ito yung magiging final setting natin. A should be, let's bring the table out, no? So let's copy this table. So A should be A2, therefore should be paste yung gagamitin natin. Tapos B should be, gagamitin natin is B2, therefore, ano ba to? Machine pressure. I think this is in MPA, no? So B2 is 375. So that's, ay no, sorry. Tama, B2 pala. Nagkataon na yung same. And this is, maganda to, no? Kasi yung B2, yung highest signal na, or highest, or yung nominal response niya is also the setting that gives you the highest signal to noise ratio. So that's MPA. Tapos C is equal to mixing time. Mixing time natin is, this is in minutes, no? So we choose C should be 2, so 90 minutes. And D is temperature, and D, you can choose, no? And ako, if I were to solve this, I would choose D as a control setting. So, ang gagawin ko is D should be 275 degrees Celsius. And bukod doon, I could also argue, if you look at this, 275 degrees Celsius, this is a lower temperature din siya. 350, 425. So, parang bukod doon sa, parang umaasa na lang ako sa B2 and C2 para ma-adjust yung settings ko. Bukod doon, pwede ko rin i-argue na yung lower temperature requires lesser cost, no? Kasi usually if you want elevated temperature, a process that is done at elevated temperature usually costs more, no? So pwedeng dito, bukod doon sa mababa na nga yung cost niya, ang nangyayari pa is mataas pa yung parang control niya doon sa variability. Okay, so kumbaga pinapababa pa niya yung variability ng process. So my argument has or I have two cases for my argument, no. It is lower cost and it brings up my or it reduces my variability. Okay? So ito yung magiging final. So you can answer this way, pero for me, I just like to see this type of answer, no? Yung naka-natural settings na siya para mas ma-imagine natin. And it sometimes also helps, no, to in your decision making. Looking at it from the natural settings point of view gives you an idea kung, or gives you a more solid na basis, no, for choosing the right settings. Bukod dun sa ano na to. So you can do this, you can also do this. Okay? So, questions before we take a short break. Okay naman?
Wala naman po, sir.
Okay, so yun yung Taguchi 2. So Taguchi 2 again is used for optimization para makapagpili tayo ng right settings for our process, no? So we do two ANOVAs. Yung ANOVA 1 natin is for the response. Ito yung pipili tayo kung alin yung signal factors. Tapos ANOVA 2 is for the signal to noise, which ang conclusion natin would be to determine which are the control factors. And from there, pwede na kayo mag-make ng engineering decision kung ano yung magiging final settings nyo based on which are signal and which are control na factors. Okay? Okay. So if there are no questions, 10:20 ngayon, let's take a short mga 10-minute break siguro, 10:30. Balik tayo 10:30. Tapos we'll discuss, although hindi na to kasama sa exam, no? Yung i-discuss na natin is for the next exam naman to. This is regression, no? We'll cover the first half of regression muna. Tapos after regression, um pwedeng yung second half ng regression, if may, kung kulangin tayo ng time, second half next week na lang natin siya gawin sabay sa ano sa RSM, no. Okay? So take a short break muna, guys. I'll see you in 10 minutes. Okay, I think we can resume now, no? So ito, ang ipapakita kong methods actually super simple lang, no? For linear regression. And you can choose either of the three methods na ipapakita ko ngayon. But two of them are parang one-click methods, kumbaga. Yung isa is actually much more complicated, no? Pero pwede nyo gamitin siya or yung formula na ituturo ko can actually be applied to other uh, forms of problem, no? Hindi lang doon sa linear regression. Okay? So let's start, no? PowerPoint. Okay? So regression analysis is just ano, no, parang gusto natin makakita ng parang linear relationship between two factors. So we call the independent variable as your regressor. Tapos yung response variable natin, ang tinatawag natin sa kanya is the regressant. Okay? So minsan tinatawag din na predictor yung regressor, no? So it usually comes in the form of the y equals mx plus b na form, no? So here, y again is the dependent variable or the response variable or the regressand. Tapos yung x natin is the independent variable, also known as your predictor or the independent variable. Okay? So dito, this is a simple linear regression, no, wherein isa lang yung factor na tinitingnan natin. And this can be applied to yung mga studies nyo, no? If you want to know if there is a linear relationship between two factors, then you do regression analysis. Okay? But we can also extend linear regression analysis to multiple factors, no? And in that case, we call them as the multiple regression analysis. And pwede natin i-discuss siya sa next meeting or if we have time today, pwede rin kung kaya natin matackle today din, no? Okay? So, it usually is in the form of y equals mx plus b. In this case, it's y is equal to b naught plus or beta naught plus beta 1 x, where beta 1 here is the slope or this is the m, no? Tapos yung beta naught is yung b doon sa mx plus b. Okay? So if you have multiple factors, magiging ano lang to na y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, etc. etc. Okay? Pwede rin if you're familiar with M's and B's, no? Pwede rin naman y is equal to M1 x1 plus M2 x2 plus M3 x3 plus dot 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 tapos plus B. Okay? So you can show it in any way you want, no? Let's just use for simplicity, gamitin lang natin MX plus B, no? So M1s, M2s, M3s tapos B yung magiging intercept natin. Okay? So, we're familiar with the linear equation, no? So hindi ko na kailangan ano to, parang i-illustrate pa. Pero basically what we're saying is, and in most normal processes kasi sa ano, no, in the natural world, usually meron talagang linear relationship between them or there can exist a linear relationship between them. So that's why regression analysis is important because you can actually produce a model, and from that model kaya natin mag-predict ng certain values, no? So for example, from historical data, we produced a regression model, and with that regression model, for future instances, kaya natin i-predict kung ano yung magiging response natin. So for example, if I have historical data na let's just say may historical data ko o parang the average weight ng isang person based on the amount of food they intake, parang ganun. So, if I have that historical data, I can produce a regression analysis. And now, if I were to use that model, yung regression model na na-produce ko, which is in the form of y equals mx plus b, pwede ko nang by knowing a particular x values, yung independent variable ko or the regressor, kaya ko nang ma-predict yung magiging response niya. So for example, if I want to know I have this amount of food intake, ano yung expected ko na parang y value nun. Okay? Or response variable nun. So, kaya importante itong regression model, no? But it must be noted, no, na si regression must not be confused with causation, no? Because in no way does the existence of a statistical relationship between your y or your dependent and your x or your independent, there's no way does this imply na meron silang causal relationship with each other. So parang hindi natin, when we already figured out na meron silang statistical relationship, linear relationship that is, no, between them, hindi natin pwede sabihin na x causally affects y. Okay? So there just exists a relationship between them. So no cause and effect pattern is necessarily implied in the regression model. Okay? So again, simple regression model. This is example of historical data, no? And feel ko from your previous na mga ano, no, mga for example labs, no, feel ko in a way gumagawa na kayo ng regression analysis kahit hindi nyo alam na regression analysis pala yun. So minsan may mga data tayo na ganito, tapos yung nagli-linear fit tayo, that is actually linear analysis na. Okay? You are, when you do yung sa Excel, parang ang ikinocompute nyo yung parang closest line. So nagbe-best fit line kayo tapos may lumalabas na R squared value. Yung mga ganun. That is regression analysis. No? So you've already been doing this. So this should not be something new to you guys. So again, ito parang ano to, parang linear relationship between a lab scale na defect versus yung actual na field scale na defect. So they can see na parang may linear relationship sila, no? So you can do a modeling such that if you do future experiments, kunwari meron kang lab detect defect size of 60, you can estimate using the model kung ano yung expected na parang defect niya when it comes to the field naman. Okay? So, ang gagawin natin is we'll use the least squares method, no, para ma-solve um yung yung M's and B's natin. So in this case yung beta 1 or yung M1 pati yung SXY natin, which is yung sum of uh, sorry. Gagamitin natin yung XXY para ma-solve tong beta 1 and beta 2. Although yung ituturo kong method sa inyo, hindi na actually kailangan i-solve tong values na to, no? Okay? Yung 3 methods na ituturo ko, hindi nyo na kailangan siya. Okay? So, ito yung ano natin, two equations, but we can actually convert these two equations into matrix form, and this is its matrix form, no? Parang ganyan siya. So, that's n. Ito summation of mga xi's natin. Ito summation of xi. This is the same value, no? Ito summation of sum squared kumbaga to. Summation of the x squared. Ito beta naught, beta 1. This is just your b. This is your m1. Ito summation of the response. And ito sum product to. xi, yi. Okay? So, try natin to. Well, let's do this problem, no? Meron daw tayong, sorry. May no fines concrete tayo made from a uniformly graded coarse aggregate and cement water paste. Tapos, this is beneficial in areas prone to excessive rainfall because of its excellent draining properties. So, let's use the least squared analysis or regression analysis to compute, to show how your y, which is in this case porosity percentage, is related to your x, which is the unit weight or the PCF in terms of PCF in concrete specimens. So consider the following representative data, tapos try natin extract yung linear analysis na to. And Pico, without any knowledge of linear regression, no, kahit hindi ko ituro sa inyo to, Pico, meron kayong mapoproduce pa rin na, ano, no, na linear model. Okay? So, let's use this. Tapos, punta tayo sa Excel natin. Ito yung data natin. So, we have your X and Y's. Ito siya. Tapos, ang gagawin natin is, let's first use, yung first method na ituturo ko is yung matrix na method, no? Okay? So, let's use this matrix method here. So, ito yung matrix na dapat i-form natin. So, I'll do a matrix, gagawin ko dito, this is my, I'll just say na ito is A times B is equal to C. Okay? So I have A times B. Ano, so, apat siya. So A times B is equal to, oh, sorry, C. Okay? Ang ganyan. So my A here is N. N is just the total. So we do count. Ito. So total, kumbaga, this is the total paired observations, no? Parang ganyan. Or parang, kumbaga, coordinate points. Parang ganun. Sa X and Y's natin. So we have 15 points. Ito. Tapos, this summation of xi here is equal to the sum ng xi. This is the x column. So sum lang natin siya. And same dito sa side ito. So same lang dapat siya. No? Kasi ito naman, this is the sum square. So we do equals sum square. So we have that. Tapos, dito naman sa beta, so we are multiplying dito kasi para mas malinaw na. Ilagyan ko ng konting space. So I'm saying na ito, multiply ko by this matrix. Okay? So matrix, the beta matrix here is ito yung hinahanap ko, no? So beta naught is your B. Tapos ito M1, no? Since isa lang yung X natin, so M lang isasabihin ko. So this is B, this is M. Okay? And that is equal to yung C natin. Okay? So C natin is equal to yung summation ng Y, which is this one. And ito, yung itong dito sa part na to, ng C matrix na to, is equal to xi, yi, summation ng xi, yi, which is just equal to sum product lang yan. No? Sum product nito with this one. Tama? So you get these values. No? So this is A times B is equal to C. And if ano kayo, linear algebra na kayo, you'll know that if A times B is equal to C, then you can also do A times C prime is equal to B. Technically, hindi siya C prime talaga. This is C inverse of C. Tama? If you take the inverse of C and multiply it by A, then you get B. Okay? So what we'll do is, kunin muna natin si inverse ng C. Tama ba? Baliktad, sorry. Dapat A prime. Tama. Matrix multiplication natin. Dapat kasi si A yung ililipat natin sa kabila. So technically parang ginawa natin is B is equal to C times A prime. Parang ganyan. Okay? So, gawin natin is equals, kunin muna natin si A prime, no? So, what we do is M dot, sorry. M inverse. Ayun. M inverse. The formula is M inverse. And we take the array, no? Now, the any matrix calculation sa Excel requires that you do an array function, no? And array functions are done by instead of regular pressing the enter button, no? That's the regular way we do it. See, array functions requires that you press Control Shift before you press enter. So, gagawin natin is hold natin Control and Shift and press enter. Okay? So, dapat, wait, bakit ganun? M inverse. So, let me do that again. equals M inverse. Okay. So it needs the ano pala class, no? Kailangan mo i-select muna yung um, array kung saan mo gustong ilagay yung answer. Okay? So gawin natin is M inverse. Ganyan. Okay. Kahit pala hindi siya i-array function, no? Kahit hindi nyo i-control shift, mukhang the newer versions of Excel, automatic siya na yung mag-detect. So ito, kung mapapansin nyo, naka-highlight na kung ano yung ano niya. Okay? So, ito yung answer natin sa M inverse na function, which is taken from this one. So, inverse to ng A. And now we just need to multiply it by C para makuha yung B natin. Okay? So, if we take B, and let's just place it here, no? So, if we do, again, isa-select muna natin ito kung saan natin gusto ilagay yung answer. Tapos, we do M mult. And that is the array function for, or the function for multiplying two matrices, no? So, M mult ng first array, which is this one, and second array, which is this one. And we should get these two values here. Now, these two values is equal to B and M. Okay? So, ito na yung B natin, ito yung M natin. So, our regression model now becomes Y is equal to negative 0.8965 plus 117.902. Yan yung magiging regression model natin. Okay? So that's the matrix method. Meron din tayong yung second method, which is yung line-nest na method, no? So we use a function called line-nest. Tapos si line-nest, gagawin natin is meron siyang 3 arguments, no? So first argument natin is itong y. So ito yung known y's natin. Second argument is the known x values. So ito siya. Kung wala kayong nilagay dyan, so kung ang ginawa nyo, saglit lang ha. Kung wala kayong nilagay dito sa second na argument, ang mangyayari is, iti-treat niya as if 1, 2 integers lang siya. So para magiging 1, 2, 3, 4, 5, 6 hanggang 15. Pero since meron tayong values for x, ang gagawin natin is i-input natin yung array for the known x's. No? So ito siya, known x. Tapos yung third argument is yung constant. No? So this is if kumbaga kung gusto nyo na iset yung intercept niya equal to 0 such that yung line nyo kumbaga intercepts the y-axis at 0, pwede nyo siyang piliin yung false. So we set it equal to 0. Pero kung gusto nyo i-calculate siya normally, which is usually the case, no? Gusto natin there are some cases lang na kumbaga kailangan natin i-force na the intercept is equal to 0, no? But in most cases, we can calculate it normally using the linear regression analysis. No? So gagawin natin dito false lang. True yung gagawin natin. Or you can write in 1 to signify true. So true siya kasi gusto natin compute lang siya normally. Ano ba yung examples wherein we force b is equal to something? Wala akong maisip top of my head ngayon, no? Inisip ko dislocations pero baka hindi nyo pa alam yung mga dislocations. Kasi it's a physical metallurgy concept. No? Pero anyway, sa ngayon, we just compute it normally. No? Unless i-force talaga natin na parang gusto natin mag-intercept yung model natin, yung produced model natin doon sa y-intercept at 0, then you can do that. You can do the false argument. No? Pero this time, true lang yung ilalagay natin. Okay? Tapos yung stats, additional stats is if you want additional na statistics dun sa ano natin. So let's input additional stats, no? So let's do true as well. Kasi mapoproduce nyo is something that looks like this. So dito ang first dito sa taas is siya parati yung ano natin, mga intercepts, yung mga coefficients kumbaga. So ito yung Starting from the left, siya yung highest na coefficient. So if we have 3, kunwari, sa Linus function, ang mangyayari is, ito yung B3. So M3, I mean. So magiging M3, M2, M1, tapos B. Parang ganun. Or beta 3, beta 2, beta 1, beta not. Okay? So kung meron kayong 4, so magiging M4, M3, M2, M1, tapos yung B. Okay? Pero in this case, since dalawa lang to, etong first is just the M1, which is just M. Tapos etong second is the B. Okay? So just to show you class, no, lalagay lang tayo ng random kunwari. Lagay ako ng random numbers. Ay, sorry. Randomize ko lang para may konting linear pa rin siya, no? So if I do the Linus function, no, tapos ang known x ko, and I have to place this. Ay, sorry. So kunwari lang x1 to and this is x2, no? If I do a Linus function ulit, known y ko is this one. Known x ko is this array here. Tapos let's do true. Mangyayari is, you'll notice na meron siyang additional na columns, no? So this is yung first column, second column, third column. So ito, this means na ito yung para sa M2. This is M2, this is M1, and this is B. Parang ganun siya. Okay? So pagka meron naman tayong three columns, three regressors, mangyayari is magkakaroon kayo ng fourth column pa niyan. Okay? Or in this case, simple lang naman tayo. So, dalawa lang. So, ito yung lalabas sa Linus function. And let me move it here, no? So, yung same tayo na nakuha ng M, no? That's negative 0.8965. Tapos, yung B natin is 117.902. Tapos, ito. So, this is M and B, no? Yung nandito sa first na row. Dito, ito mga standard errors ang tawag dito, no? So, this is the standard error for hindi na masyado natin tinitingnan itong standard error, no? Pero it is there if you need it. Tapos ito, this is actually your, let me double check, no? Para makita nyo, you can actually just click the line nest function. Tapos, nandito naman siya. And sometimes I forget this, no? So, nandito naman siya. The table looks like this. Ito. So, you can see na standard errors yung third. Tapos ito, the first dito, this is your R squared. Ito, this is the standard error for the Y. Okay? Tapos ito yung F value niya para sa ANOVA. Ito yung F calculated. Tapos ito, degrees of freedom. Ito yung SS ng regressant. Tapos ito yung SS ng residuals. Residuals is yung error, no? And later, I'll show you how to make the ANOVA table. Okay? So this is the line nest function. So madali lang din gamitin yung line nest function, no? So this is R squared. And this is your standard error for Y. Ito, this is F calc. Ito, degrees of freedom. This is SS regression, which is SS regression is technically parang pwede nating sabihin na SSA na lang, no? Or SSR na lang sabihin natin. Tapos SS residuals is just error, no? SS error siya. Okay? So that's the second method, yung line nest function. And the last method is yung pinakasimple and mas maraming data na napoproduce. Again, gagamitin natin just data solver lang, no? So if you go to data analysis, tapos punta tayo sa data regression. Saan ba si regression? Dito, si regression. Click OK. We select our ano ito muna? Select our Y range, which is this one. And let's select our X range, which is this one. Tapos wala tayong labels. Sige, let's select with the labels, no, para maganda. So ito. Select natin with the labels. Tapos, ito yung constant is 0. Ito yung sa Linus function na yung i-false natin yung third argument. So, dito, hindi naman natin i-constant equal 0. Let's compute it normally. Confidence level natin is 95. So, let's just use the default, no? Output range, lagay natin siya dito, output range. And the good thing about this, pwede din kayong create ng mga residual plots. So, pwedeng you can do a residual plot, line fit plots, standardized residual plots, etc. So let's just do residual plots and line fit plots, no? Para additional data. So if you do this, sorry. Anong nangyari? Output range, I place it here. Yan. So you have this output. So meron tayong summary ng output. Tapos ito, yung ANOVA table nandito na rin. Tapos, nandito yung mga coefficients natin and may additional plots tayo, no, if we need them. Ito yung residual plots natin. Ito yung residual. Ito yung line fit plot. So this is the line fit plot na gagamitin natin pagka alam niyo yung pagka nag-scatter plot tayo tapos ginawa natin to. So pwedeng gawin ni Excel automatically yun using data analysis toolpack. Okay? So for now, hindi naman natin kailangan masyado to, no? So ito lang muna gagamitin natin. So we have itong ANOVA table natin looks like this, no? So meron tayong regression. This is SSR. Then you have your residuals, which is the error, SSE. So nandito siya. SSR, SSE. Tapos yung Fcalc natin is just this value, no? So this is the same, 510, 510. Tapos significance S is the p-value. So if we were to put p-value here, then we do equals fdist rt nitong degrees of freedom 1, which is the regression model always has a degrees of freedom of 1. Tapos yung regression, residual natin is just yung total minus yung 1, no? Total minus 2 kumbaga kasi minus the total residual, the total degrees of freedom is count total y values minus 1 tapos minus 1 pa for the regression model. So magiging 14 siya. 13 kumbaga. So ito yung DF 13 and you should get the same value, no? 8.07, which is this one, 8.07. Same value. Okay? Tapos dito you have the coefficient. So intercept, this is the B. Ito yung coefficient, this is the beta not, no? Itong negative beta 1 or the M1. Negative 8.8965, which is this same value. Tapos meron din siyang standard errors, which is yun nandito, no? Standard error 4.3343, 0.0396, nandito din yung standard error. Then you have R squared. Ang R squared dito, wala dito yung R squared, no? Hindi makikita yung R squared dito. Okay? Tapos meron kang p-values dito. So the p-values actually, ito, ang conclusion natin dito is it's a very small number, no? So we can say na since it is very small, it is less than 0.5, which is our, this is actually p-value, no? P-value yung significance F. So it's a very small number, therefore significant yung regression model natin. So we are saying na there exists a linear relationship between the two variables here, no? Yung x1 and y1. X and y, I mean. Okay? Significant. Tapos you can also look at, if this were a multiple linear regression model, pwede rin tingnan yung individual na p-values dito. So parang individual p-values dito shows you kung significant ba or not yung isang yung kumbaga yung intercept value niya or yung coefficient value niya. So kung significant siya, then you can use it in the model, pero kung hindi siya significant, then parang doon sa model na yun, kumbaga pwede mong i-omit yung factor na yun. So let's just say na meron tayong x3 dito, no? Tapos ang lumabas na p-value niya is 90 kunwari. P natin na or some realistic value. Kunwari, 0.23 ang lumabas. So, 0.23 is greater than 0.05. So, therefore, ibig sabihin, hindi significant yung si x3 na coefficient. So, pag ginawa nyo yung model, magiging y equals m1 x1 plus, hindi mo na isasama sorry, ba't x2 to? Kasi x2 yung pinangalan ko. Magiging x lang to, no? Tapos kunwari x2 to x1, kunwari lang x1 and x2 to. So magiging ang final answer nyo is magiging y is equal to x1 plus b lang. M1 x1 plus b. So hindi nyo isasama si x2 kasi hindi significant yung p value na dyan. Okay? So ito, pwede nyo gamitin to as a rule of thumb para pwedeng i hindi isama yung isang particular na nasa regression. Okay, sorry. Nandito pala yung mga R squared values, no. Thank you, Martin, for the correction. So if you can see, meron tayong dito, R squared value. So ito 975, this is the R squared value. We also have what we call as the adjusted R squared value, no. The thing about R squared kasi is, and I can go into more detail in the next meeting, pero nasa modules din ata to, no. Kasi pagka nagdagdag kasi kayo ng mga factors, no, or variables, usually pag ginamit nyo lang yung multiple R squared na equation, tataas talaga yung R squared nyo regardless of what you regardless if the model or if the additional variable parang is does or is has a significant effect on the model, no. Regardless kung it has or it doesn't have, tataas talaga yung R squared kasi ganun siya, kumbaga nature ng calculation niya yun. So may tendency kayo mag-overfit, no. So yun yung problema pag R squared or multiple R squared yung gamitin natin na basis for knowing if the model is has a good fit or not. So to counteract this overfitting, usually adjusted R squared yung ginagamit natin. So adjusted R squared is a tool to know if yung dinagdag nyo ba na panibagong variable really improves the model or not. So if the adjusted R squared is greater than the original R squared, then it improves the model. Pero if it goes down, therefore, if it, kunwari ito, if you compare adjusted uh, versus the R adjusted, although hindi nyo makikita dito, no, kasi one variable lang naman tayo. Pero kung i-compare nyo yun, if it becomes smaller, meaning yung new variable na dinagdag nyo dun sa model nyo actually does not improve the model. Okay? Although pwede nyo magamit to sa sa studies. In the exams, usually hindi naman tinatanong na to or hindi na namin sinasama to complicated na na to, no, concept, no, yung adjusted R square. Okay? So, ito, standard error for the Y to. So, you can see na ito, same sila, standard error for the Y. But you can manually compute this as well, no? So, if we go back to the PowerPoint, we can compute for the sum of squares of the residual using this equation, no? So, once we have the, uh, the different M's and B's. So may magko-compute kasi tayo na M and B value na, no? Tama, using the matrix. Tapos, ito na yung na-compute natin. Pwede natin ma-compute tong SS error, no? And SS error is just given by this formula. So summation of Y squared minus yung computed natin na B naught multiply by summation of YI minus yung computed natin na M1, which is yung slope 1 natin or beta 1, multiplied by the sum product of xi, yi. Okay? Tapos yung total natin is equal to ito naman. Same pa rin siya ng pag-compute, no? Doon sa mga previous na SST natin. Kukunin natin yung response variable tapos sum squared nun minus yung correction factor which is the grand total square divided by n. Okay, so let's try to form the ano, no? And ito, hindi ko masyadong memorize kasi itong ano, SSR. So, copying ko siya. So, if we were to do the ANOVA manually, ay, mali. Okay, so if we were to do manual calculations using ito, no? Itong matrix natin, we can do ANOVA, source, DF, SS, sorry, SS, DF, MS, FCalc, and p-value. So, so SS, so ito yung ano natin, no? This is your regression. Residuals is just error, no? Tapos total. So total natin, we do sum squared ng y values kasi siya yung response minus correction factor which is just sum nito squared divided by count ito. Okay? So you have 429.544 same total. Error natin is equal to sum squared of yi which is this one minus beta naught, this is your beta naught, yung b times sum ng yi minus beta 1 which is this one which is your M1 multiplied by some product ng this one and this one. Tama? And you get 10.6599 which is the same value as this one. And notice na ang difference dito class, no? Usually kasi kinocompute natin yung sa, ay hindi pala nalipat sa screen. Ito. Ulitin ko na lang. Ito, ang ginawa ko lang dito is, let me just do it again, equals sum squared nitong value na to minus correction factor is just grand total sum nito squared divided by grand total which is count yung total count and that one 429.544 which is this one. Okay? Tapos dito sa error ulitin natin, no? Equals sum squared ng yi minus beta naught which is b ito multiplied by sum ng summation ng yi which is this one. Okay? Minus yung beta 1 which is just the M1 ito multiplied by sum product naman because that summation of xi minus times yi sum product ganyan. So if you compute that, you get 10.6599. Okay? So you notice na different siya sa usual na ANOVA na ginagawa natin. No? Kasi usually, kinocompute natin yung itong SS ng source natin. Yung factors, kunwari SSA, SSB, SSC. Tapos, kumbaga, kinukuha na lang natin yung difference from the total, from the sum. Tapos, makukuha natin yung SS error. So this time, si regression naman yung kinukuha lang natin yung excess, no? So if you get total minus error, you get 418.844, which is this value. Same value, no? So DF is always 1. Total is equal to count 15 minus 1, no? 14 tas ito equals this one minus this one, which is 13. MS, add natin. Tapos FCalc is this one divided by MSE. So you get the same 510. Tapos p-value is F this RT. Ito. Yeah. Conclusion. Significant. So there is a linear regression between the two of them. Okay. Tapos if you want to calculate the R squared, value, if you want to calculate it, you just get the 1 minus SSE over SST. So let's do that. So if we do R squared is equal to 1 minus SSE natin is this one divided by SST. And we get 0.97518, which is the same dito, no? And the same din dito. Okay? So, hindi ko na ituturo tong iba pa. This is the R-adjusted R-squared na sinasabi ko kanina. And again, this only increases when the new term or new variable na dinagdag nyo actually improves the model. Okay? So, ito, just a summary. Error, degrees of freedom ng regression always 1. This is n minus 2 kasi n minus 1 siya. Tapos total is n minus 1. Tapos SST, SSE, and therefore ito SST minus SSE lang. Okay? So, pwede siguro mag-end tayo dito. Tapos, next time naman, next meeting, ipapakita ko sa inyo yung multiple regression model. And we'll do this sort of matrix calculation. No? Ito. So, you'll notice na ito, mas marami ng magiging 3x3 matrix na yung multiply natin. As opposed to kanina, which is 2x2 lang. So, ito. Makikita natin na makukuha natin is beta naught, beta 1, and beta 2, which is just B, tas ito M1, tas ito M2. Tapos gagamitin din natin yung M-molt na ano no, yung Linus na calculation. So pwedeng Linus lang gagamitin natin dito or pwede rin yung one-click na method which is etong si ano no, yung data analysis tool pack. Okay? So I think pwede tayong tumigil lang muna dito. Are there any questions? Actually, pwede kong ipakita yung pinaka, ano no? Although dito, sobrang rudimentary lang ng nakakreate dito. No? Kasi kung ito, if you select natin to, itong dalawang data na to, and you do insert, scatter plot, insert, tapos scatter plot tayo, kunwari ganyan. So ito siya, X and Y's. Tapos, ang gagawin natin is we add a trend line, linear, and we display equation chart, display our value. Actually, ito na rin siya, no? And this is also another simple way. And Pico, ito yung nagawa nyo na at least one point in your lives, no? Nagawa nyo na to. So, you see na, same lang na nakukuha, no? 0.8965, 117.902, 0.9752, same R-squared value, 0.97518, which is rounded up lang. Okay, so pwedeng ito yung gamitin nyo. Pero the problem with this, ano no, yung insert chart method lang is that although it can give you the best fit line tapos R-squared value, hindi niya kumbaga, it can only handle one variable, no? So kasi sa scatter plot kasi na to, hindi niya kaya yung 2x variables, no? Okay, so kaya ito for one single linear regression lang to. Simple linear regression, I mean. Okay, so pwede ko siguro i-leave na lang din to para may ano kayo. Ayusin ko na lang to, no? Pwede siguro like ko dito, line nest method. Okay, so ayusin ko na lang to class, no? Tapos send ko sa inyo, and with that, unless of course may questions pa kayo. Do you have any questions? So, medyo madali lang naman, no? I think kaya naman to. So, simple regression, simple. Baka sa multiple regression, medyo magiging mas complicated siya, no? Okay? So, with that, we can end the session, and thank you for coming in today. And I hope you have a good lunch later.
Thank you, sir.
Okay. Bye-bye.
Thank you, sir.
See you next week, guys. And good luck sa exam. I-release namin later. By the way, sige. I-announce ko na lang din. Pero yung sa ES1, wala muna tayong meeting ulit kasi no new lessons ulit. Magpo-focus kayo for this week, focus kayo sa take-home exam nyo, no? Or sa MRs nyo, no? Yung milestone requirements. Okay? So, see you. Okay, may tanong. Okay, go ahead.
About din pala sa exam.
Okay. Ano yun?
MME. Same format ba siya sa last exam or iba na naman yung process?
What do you mean by same format?
Kasi di ba yung last exam is
Hmm.
yung multiple choice, if I remember correctly, tapos more than one attempt. Same concept ba ngayon or iba na naman since iba na din yung topics?
Hindi yata multiple choice yung last exam.
Ay, hindi pala ano yung quiz yung iniisip ko yung last exam.
Quiz yung multiple choice. Oo.
Okay. So same, okay.
Yung last exam parang gumawa kayo ng 4 separate sheets, tama? Excel sheet.
Yeah.
Tapos in-upload nyo siya. Parang ganun din. Pero instead of 4, 3 lang ngayon. 3 for third long, tapos 3 din for fourth. Second long exam, tapos 3 din for the third long exam.
Okay. Thank you, sir.
Okay. Martin, go ahead. Ano yung tanong mo about the project?
Confirm ko lang po, kailangan po nung tatlong statistical techniques din sa project.
Yes, kailangan sana. Pero kung hindi kaya, pwede naman natin pag-usapan noon na kunwari, hindi nyo talaga kayang i-employ yung 3 techniques. Pwede naman. Pag-usapan natin sa next consultation. Mag-schedule na lang siguro ako, no? Siguro next week, di ba mag-meet tayo yung Wednesday? We can add Friday session, no, just for consultations. Ganun na lang.
Okay po, thank you po.
Okay.
Thank you, sir.
Okay. Thank you everyone for coming today and see you next week.